So today we are going to try to put all of the things we've learned together. So the x and y intercepts in the asymptotes. So I'm going to do a few of these problems with you, and then you're going to try to complete them the best you can. You have access to a graphing calculator if you get stuck. So the goal is to sketch a graph and identify the important information. So I always start by finding the y-intercept. And the y-intercept is found by plugging in 0 for x. So every time we're going to plug in 0 for x. So when I plug in 0 for x, I get 6 over 3, and 6 divided by 3 is 2. So my y-intercept is at 0, 2, and I plot that point. So the x-intercept is found by plugging in 0 for y, but basically, when you plug in 0 on the left side, you multiply this denominator to the other side. Anything times 0 is 0, so you get 0 equal to the numerator. So the shortcut is to set the numerator equal to 0. In this case, if I set the numerator equal to 0, I get 6 equals 0. 6 will never equal 0. So there's actually no x-intercept. So I'm going to skip the domain and range until the end, once I've looked at my graph, and I'm going to go to the asymptotes. So for the vertical asymptote, I'm going to look at the denominator equal to 0. What will make x plus 3 equal 0? Well, x would need to be negative 3. So x equals negative 3 is my vertical asymptote. So I'm going to put that on my graph. My last step is to determine if I have a horizontal or slant asymptote. So I look for the power of the numerator and the power of the denominator. In this case, the denominator has a bigger power, so it has a horizontal asymptote at y equals 0. So I'm going to put my asymptote at y equals 0, and then I'm going to sketch my graph. So I can see that this part of the graph must curve through the y-intercept. My guess is that this part of the graph is down in this region, but I should plug in a point like negative 4 into the original function to see what happens. So when I plug in negative 4, I get 6 divided by negative 1, which is negative 6. So at negative 4, my graph is at negative 6. So this part of the graph is going to curve in this region. So there's my function. What is the domain? So x goes back and forth on everything except for negative 3. So x cannot be negative 3. And my y values go up and down except at y equals 0. So y cannot equal 0. So then there's this thing that says analysis at the bottom. What is happening to the function as x goes to infinity? So it's asking you about this end of the graph. This end of the graph is approaching 0. What about as x approaches negative infinity? So it's asking you about this part of the graph. Well, this part of the graph is also approaching 0. Then they're asking you about what's happening by these asymptotes. So negative 3 is the asymptote. If it says from the plus side, that means from the right. What's happening on the right-hand side? It's shooting up towards positive infinity. Negative means from the left-hand side. As I approach negative 3 from the left, my arrow is pointing down towards negative infinity. So let's do that same process again. So start with number 2. For my y-intercept, I'm going to plug in 0. I get 19 divided by negative 76. So that's a decimal, right? 19 divided by negative 76 is actually the fraction negative 1/4. 0, comma, negative 1/4 is my y-intercept. So I just kind of put it there between 0 and negative 1. And my x-intercept, once again, if I set the numerator equal to 0, I cannot get it equal to 0 because it's 19. So there's no x-intercept. Skip domain and range for a minute. My vertical asymptote is going to happen when 38x minus 76 equals 0. So I'm going to add the 76 to the other side and divide by 38. And 76 divided by 38 is just 2. So x has to equal 2. So that is my vertical asymptote. Now I have to look and see the powers of the numerator and denominator. The denominator wins. So y equals 0 will be my other asymptote. So this graph is going to look very similar to what we had in number 1. So a curve down here through that y-intercept, probably going to be up here in this region, but I'm going to plug in positive 3 to see what I get. I'll show you doing that. So if I take 19, oops, it's kind of hard to see. Hang on. There we go. So if I take 19 and I divide by 38 times 3 minus 76, close parentheses, I get 1/2. So at positive 3, my graph passes through the point 1/2. So this end of the graph is over there. So let's see, my domain just cannot equal 2. X cannot equal 2. And my range, again, is y cannot equal 0. Asymptotes have equal signs. Domain and range restrictions have cannot equal signs. Let's do our analysis. As x approaches positive infinity, the graph again is approaching 0. Same thing on this side with negative infinity. And what about as the graph approaches 2 from the right-hand side, the graph is going up towards positive infinity, and then again down towards negative infinity. So because these two graphs behaved similarly, the analysis down here came out the same. So let's look at a different example. So I'm going to look at number 3 and 4 here. All right, so on number 3, I start with my y-intercept. When I plug in 0, I get 1 over negative 6. So my y-intercept is at 0, comma, negative 1/6. My x-intercept, again, is none because my numerator can never equal 0. My numerator is 1. Skip my domain and range for a minute. What about our asymptotes? Where will this denominator equal 0? I need to factor it first. So I'm looking for the factors of negative 6 that add up to negative 1. So would you agree that's x minus 3 times x plus 2? So my two undefined values are at positive 3, because it makes that 0, and negative 2, because it makes that 0. 3 and negative 2. So here's 3. Here's negative 2. And my denominator, again, is bigger than the numerator. So my third asymptote would be, again, at y equals 0. So I have 3 regions of the graph to worry about. When I plug in the point 4 over here, 1 divided by parentheses, 4 squared minus 4 minus 6. I'm at the point 1/6. 4 comma 1/6 is about here. So this part of the graph kind of goes like that. What about when I plug in the point over here of negative 3? So 1 divided by negative 3 squared minus -3 minus 6. Gives me again positive 1/6. So here I'm again at positive 1/6. So probably what's happening down here is this upside down parabola. It would be good to test another point like -1 and +1 and just double check what's going to happen. So if I plug in, I'm just going to change these values to -1. So -1/4. So at -1, I'm at -1/4. And what about at +1? So if I just delete those negative signs, I'm at negative something there. So it's good to check. This would be kind of more of a graphing calculator question so that you could check that all your regions were correct. Let's just check if it looks like what we got. So it looks pretty good, right? So my domain is everything except my two asymptotes. X cannot equal 3 or -2, and my range is Y cannot equal 0. So I'm going to leave you example 4 to try on your own because it's very similar to example 3, right? You've got a denominator that you need to factor, check your different regions, maybe use a calculator. I'm going to skip down and try number 5 with you because 5 has a bigger numerator this time. So x squared minus 9, all right, so let's go in order here. So the y-intercept, when I plug in 0, I get positive 9 because -9 divided by -1 is positive 9. So 0, 9 is way up here. My x-intercepts, I have to factor the numerator. So x plus 3, x minus 3. So I actually have x-intercepts at -3 and +3, 0. And my last step here is figuring out my asymptotes. X equals 1 is my vertical asymptote. So now I need to figure out where the powers are bigger. The power's bigger in the numerator, so I'm going to do some division. I'm going to pick synthetic division. So I'm plugging in +1 into 1, 0, and -9. I'm putting the 0 in for 0x. Bring down the 1. 1 times 1 is 1. Add these together. 1 times 1 is 1. Add these together. It looks like y equals x plus 1 is the slant asymptote. So I go to +1, and I do a slope of up 1 over 1. So this graph must kind of bend towards the two asymptotes and bend towards the two asymptotes like that. So the domain, again, is just what our vertical asymptote x cannot be 1. And our range is actually all real numbers. So when there's a slant asymptote, it's all real numbers. So the last one I'm going to do with you is number 6. And I'm going to leave you to try 4 and 7 and 8. And I'm going to write weight on number 9. So you're going to have to do 4, 7, and 8 when I finish here. But the last one I'm going to do with you is number 6, because this is another type of asymptote where the powers are equal on top and bottom. So I'm going to again do my y-intercept first. Plug in 0 for x. I get -7/5. 0, -7/5. Which is more than 1, right? So -1 and 2/5. My x-intercept is going to be where the numerator is equal to 0. So add 7, divide by 6. So positive 7, 6, right? If I set that equal to 0 and solve. So 7, 6. Let's see, my asymptote for the vertical asymptote, if I set that equal to 0 and solve, I'd get negative 5 halves. Subtract 5, divide by 2. X equals negative 5 halves, which is negative 2.5. There. And my horizontal asymptote, I strip the coefficients of x. So y equals 3. 1, 2, 3. All right, so I can see that this is down in this region. So I need to test a point over here. 1, 2, 3. So plug in negative 3. So 6 times negative 3 minus 7 over 2 times negative 3 plus 5 would give me what? Negative 18 minus 7, negative 25 over negative 6 plus 5 would be negative 1. So it looks like positive 25, which is way the heck up here. So something in this region that would look like that. My domain again is just x cannot be negative 2.5. My range y cannot be 3. Should go along with your asymptotes. All right, so I'd like you to finish number 4, take a picture and submit it. And I should see your steps, what you did, and you can check it on a graphing calculator. And then on the next page, you only have to complete 7 and 8 and take a picture of this page. We will start face-to-face doing number 9 together as a warm-up. So you only have 3 problems to finish for today. Number 4, go through your steps. Number 7 and number 8.